Welcome friends to Parijat sir's classes. Hope you all are very fine now in this lockdown, so you are safe and you are at home. You are fully following the guidelines of what our government is telling in this situation. Well, the present scenario is very tough for the students as they are facing a lot of problems, as we all can understand. For that, we are all taking the online classes, so it is for your benefit that I am conducting all these classes so that you can just follow my class and then everything will be very easy for you. So that won't be a problem. Any chapter of physics, I will be teaching physics as well as mathematics, so you won't have any problem. I will be dealing some very good questions in physics from the JEE mains, from the advanced, from IITs, all the type of questions I will be dealing here, plus I will be giving you all the basics about every individual chapter of physics. So you have to keep following me, because I will be going one chapter at a time and I will be discussing the important chapters of class 11. So keep following with me, subscribe my channel, press the bell icon and keep getting all the new notifications which I'll be giving from here, so that you can get all the updated classes. Okay, so today's class is about the dimensional analysis. What I will do is that I will not go to the very basics, because there are some chapters which require not so much theory. They are basically those chapters, they are only related to the approach of the numericals, how to do those. So you don't have very much detailed theory in those. Okay, so the first chapter I start today of class 11 physics, that is dimensional analysis. So what is dimensional analysis? Let's make it very simple and very straight. Dimensional analysis is based on three major terms, which is the mass. We express it as n, and then we have the length, which we express as in L. We have the time, we express it as T. We have the current, which we express it as A for ampere. I hope you have all studied in class 10 that current means SI unit of current is ampere. So we'll be dealing with this. So initially what I will do is that, initially I will make you understand how we are dealing with all these variables in dimensional analysis. For example, when we try to express a certain term like velocity, acceleration, force, then you have got the momentum. So these terms, when you are expressing in terms of dimensions, how to express it. So first of all, I'll show you how to express each and individual term of physics in dimensional analysis and how to use them. So first of all, let us see how is velocity expressed. So velocity, as we know, it's the distance traveled, that means the length, by the time. It's the distance traveled by the time taken. So what we are showing here is that it is L by the T, which means I can write it as L T minus 1, and because it does not have mass with it, so I can easily state as m0. So this is the dimensional formula of velocity. Similarly, if I want to write acceleration, so we know acceleration is all about velocity by the time. Velocity we already expressed, m0 L t minus 1 by the t. So what can we write? m0 L t minus 2. So this is the dimensional formula for acceleration. Second and third, if I want to write force, so how do we write force? Force is mass into acceleration. That means m0 lt minus 2. That means it will be m l t minus 2. So I hope you are getting some idea how to express each and individual term. Very simple terms. I'll be dealing with certain good terms also. How to express these terms in terms of the dimensions. Basically the mass, length and time. So let us come to the next term, that is momentum. So momentum is what? It is the mass into the velocity. So that means I can express it as m l t minus 1. This is momentum. Next is impulse. What is impulse? Impulse is force into the time. Now we have already studied what is force. Force is m l t minus 2 and t. So we can get it as m l t minus 1. So you can see that momentum and impulse are having the same dimensions. Momentum and impulse, they have the same dimensions. Next is work. What is work? Work is force into the displacement. So force already we have studied. We have seen that m l t minus 2 and displacement is the length. So we can write it as m l square t minus 2. This is the dimensions of the work. And work, energy and work, they are all same things. Energy and work, all these are same things. Next, if I write here another term which we see, that is stress. What is stress? Stress is the force per unit area. So what is the force? Force is m l t minus 2 and area is what? It will be L square, because length into breadth. Length is expressed as length and breadth is also a length. So length into breadth, which is L square. That means it becomes m L minus 1 and t minus 2. So this is the dimension of the stress. Second, we can see another one, that is strain. Strain. What is strain? Strain is the change in the length, change in length by the original length. Change in length by the original length. So here we can write, how do we express change in length? Change in length is the length only. For example, if there is a 5 meter length and it has become 7 meters. So 7 minus 2. 7 minus 2 is what? 7 minus 5 is 2 meters. So what is 2 meters? 2 meters again is a length. So change in length is a length only, and original length is a length only. So basically it does not have no dimensions. It does not have any dimensions. So neither it has got any mass, nor it has got any length, and nor it has got any time. So this we can say that strain is a dimensional unit where you don't have any dimensions to express it. Okay? Okay, so next what we can see, that is angular velocity. Angular velocity, omega. What is angular velocity? It is the angle. It is the angle. Angular velocity is the angle by the time taken. So how do we represent angle theta? It's the time taken. So remember one thing, that this theta actually has no dimension in dimensional analysis. Theta does not have any dimensions in the dimensional analysis, so we can take it as only t minus 1. So this is the dimension of the angular velocity. Next we can see angular acceleration. Angular acceleration, we represent it as alpha. So that is actually the angular velocity by the time taken. The angular velocity was t minus 1 by t. So it is actually t minus 2. That is the angular velocity. Next, we can see another thing, that is angular torque. Angular torque, and it is represented as J. Angular torque is represented as J. So what is the formula? It is the moment of inertia. It is the moment of inertia into the angular velocity. Moment of inertia means don't worry about the terms. What I am telling you is that because you are in class 11 now, so class 11 there will be certain terms which you will be getting accustomed to later when we will be discussing more and more chapters in physics of class 11. Then you will be getting accustomed to those terms. So don't get very much terrified now that what are these. I'm just making you introduced to certain terms so that when we will be doing some numericals, it will become little bit easy for you. So moment of inertia, which we represent as I, and angular velocity, already I told you, is omega. Now what is moment of inertia? That also I am telling you. Moment of inertia is actually the mass into square of the distance. Square of the distance. So how do we express it? We express it as m into L square. So this is moment of inertia. And angular velocity already I have shown you. So let us see how does the angular torque represented. So moment of inertia was m L square, and angular velocity, already I have given you angular velocity, which is t minus 1. So it comes out to be m L square t minus 1. So this is the representation of the angular torque which we talk about J. Now I am not going into very much detail because all these terms I will be discussing. Angular acceleration, angular velocity, angular torque, all I will be discussing. So you don't have to worry, just know what are the dimensions so that it becomes very much easy. Now what I will do is that there are actually many terms, so it's not possible. There are more than 150 terms in physics which we can actually show the dimensions, but it is not possible for us to show. So when the numericals will be done, at that time only, if I am coming across certain terms, then definitely I'll try to show you how the dimension of that particular term is being coming. So in the numericals only, I'll show you. So basically what we have learned till now is that dimensional analysis is not only about representing certain physical terms in terms of three basic units, which is the mass, the length, and the time. So we are representing this in terms of three basic units: mass, length, and time. So now we will be seeing further that how we are going to implement these dimensional analyses, all these formulas which we have derived. We have analyzed all these formulas. Now I will be showing you how you can implement it further, okay, and solve numericals. So let's see that. The first thing which we will be seeing in the dimensional application of dimensional analysis is conversion from one unit to the other unit. Suppose we can convert from SI to CGS or CGS to SI, any one of them. We can convert from SI to CGS or CGS to SI. So I am showing you how to convert. First of all, see this formula: N2 M2 L2 and T2 to the power A, B, C is equal to N1 M1 to the power A, L1 to the power B, and T1 to the power C. What is it? This basically is the initial value given. Initial value given. Initial value given. Now what is it? What is this? The final value obtained. The final value obtained. Final value obtained. Initial value which will be given to you. Okay? So, these are the quantities given in the first system of units. What is the first system? They might ask you SI to CGS. So SI will be the first system of units. They might ask you CGS to SI. So CGS will be the first system of units. And these are the second system of units. That means you have to convert it like from SI to CGS. So SI is the first system of units, CGS will become the second system of units. Or CGS to SI, CGS will become the first system of units and SI will become the second system of units. So this is how we will be going. So let us see how it happens. Okay, so convert 1 Newton to CGS system. So I want to convert 1 Newton. Now Newton is an SI unit. So we want to go from the SI to the CGS. So let us see here. N2, as you remember, I could have easily written as N1, M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. So here N1 is actually 1 Newton. I told you that N1 is the initial value. In the first system of units, what is the initial value? And N2 will be what I will get in the CGS system. So N1 is 1. Now, here we are converting from the 1 Newton to the CGS. So this is SI. And in SI, mass is represented as 1 kg. And in the second system of units, M2, mass is represented as 1 grams to the power A. Second, length in the SI is represented as 1 meter and here we represent as 1 centimeter. Time in the SI also it is 1 second. In the CGS also it is 1 second. Okay, so now let us see. Watch one thing. 1 Newton is actually what? It is a force. That means it should be 1 kg into 1 meter per